Ladies and gentlemen, welcome to the closing panel discussion of the second Mechanical Engineering and Metalworking Business Forum happening in Jelgava. And even though this panel discussion is closing, is at the end of the agenda, in my opinion, this is the most important topic we have here to discuss. And the topic is about education. Education as a support for industry, for innovations, and the new product development in Jelgava, in the region, and in Latvia. And as you probably know, Jelgava is a university city, and therefore, to start with and to explore the opportunities that the university, Latvia University of Agriculture, is providing you, the industry, providing us with, I'm inviting the Vice-rector of Studies, Professor Mr. Aigars Laizāns. Applauses, please.
Dear colleagues, I'm honored to speak to such a nice audience. You know, even if I'm a professor and a mechanical engineer, I made a lot of notes during the day. As you know, professors should already know everything, but I did still made the notes. Well, looking at the audience, I understood that those who left this room probably thought, what the hell? University of Agriculture and Metalworking and Mechanical Engineering Forum. Well, if you're... Sorry. The same question is being raised by my colleagues from different faculties when they approached foreign companies, foreign universities, and looking for engineering colleagues and friends. They are asking, what the hell are you doing and who are you at University of Agriculture? Well, in Russian it's even worse, that's сельское хозяйство. Where is metalworking and engineering? Well, and the picture shows probably the view on agriculture and University of Agriculture as it is. In reality, it's not true. I'll tell you a big secret. It was said during the second presentation today that do unexpected. Well, we did. Still, this is big secret. Please switch off video, and because it will happen just in March. But we will change our name to University of Life Science and Technologies in English. In Latvian, we will stay the same name as we are, but for foreign companies and foreign universities and partners, we will be the University of Life Sciences and Technologies. What does it mean? Why? Because we are really leading university in bioeconomics and life sciences. We have 8 different faculties. We have a lot of study programs which are based on STEM, science, technology, engineering, and mathematics. And we are the ones who are, as the mayor of the city said, and other speakers mentioned, we are the ones who support Jelgava city and the region to build up again engineering as a strong branch of business in the region. And we are helping the mayor and the city. Of course, our graduates are high-level managers, well-known scientists and entrepreneurs. You can see the structure and why we can talk about different areas in bioeconomics. We are covering all important areas, starting with veterinary medicine, then agriculture, forestry, and food technologies, wood processing, and landscape architecture as unique directions. As well as we have supporting areas in environment management, construction, energy, and mechanical engineering fields, as well as in information technologies. Why we call this bioeconomics? Because agriculture doesn't necessarily include everything. And our faculties, 8 of all of them, they are supporting bioeconomics from different points of view, different perspectives. We have, all over, we have 4,200 students. Almost 3,000 students are involved in STEM programs. You can see here different areas of education which are connected to the technology. It's not pure agriculture, it's life sciences and technologies. 44 study programs, which are at most part for Latvian needs, but we are also exporting our knowledge, especially in veterinary medicines and other fields as well. We have very strongly developed staff. We have good scientists. And if you can see, look at the age structure, it seems like we have quite smoothly structured age structure, meaning that knowledge is being transferred from one age group to another. So we are keeping knowledge inside university, we're keeping knowledge management as well. As well as we have highly developed positions in education and science. We are investing money. Of course, we would like to have more money from business, especially in engineering fields, because it's really costly to educate students or graduates in engineering fields. Those two grants from European money are devoted to, first of all, 3 million are to the STEM program development, and 15 million, almost 16 million, will be investments in the nearest 2 or 3 years in science related to bioeconomics, related to somehow engineering. I'll tell you why I'm not talking about direct engineering fields, but connections to engineering. During today's session, I was listening to the presenters, and a lot of people were talking about engineering, metalworking, mechanical engineering as closed system. Of course, we are preparing them, and my colleague, Professor Dukulis, will tell you about deeper information about the engineering, preparing of engineers. But I'll be a bit more provocative. From my point of view, pure mechanical engineering or metalworking will become a rarity. Why? Because we will need somebody else who will come with a knowledge outside just engineering and outside metalworking. If you'll need, and that's why I've already mentioned company Perusa, who presented fantastic approach, which we didn't discuss it before, but we can do the same approach. We cannot talk about pure mechanical engineer who will prepare technologies and equipment for, let's say, food technologies. We need technology, somebody with knowledge of food technology to prepare the machinery for food technology. We need somebody from forestry to prepare some metalworking instruments or mechanical engineering tools and stuff for wood processing. So combined knowledge, and our university can offer such combined knowledge because we are already in all those fields, including mechanical engineering and metalworking. So somehow this joint effort of all directions will become as a success story for Latvia, I think so. And my point of view is business should use university as something unique because we have unique properties. We are already in a lot of fields and we can cover knowledge which is needed for new technologies, new equipment, and new designs. Our approach, first of all, is 1 + 1 is a bit more than 2. As a minimum 2.1, if there is a good system, we can talk about 3, 4, and even more. Why? Because we can offer a lot of knowledge from different perspectives, and we are really waiting for people to come with needs to have more knowledge than we can talk about. So, today's first session was yes we can. Believe it or not, University of Agriculture, or right now in the next months, University of life sciences and technologies? Yes, we can. And we are thinking big, doing small steps, and doing good things at this moment. Thank you, and I'm waiting for questions.
That was great. Thank you very much. For now, you can take your seat. And to explore further the opportunities of the University of Latvia, the Latvia University of Life Science and Technology, yeah, I invite Dean of the Faculty of Engineering, Mr. Ilmārs Dukulis. Applauses, please.
Hello, everybody. Faculty of Engineering is located on the best place in Jelgava, near river Driksa, near our new pedestrian bridge, and this place is even better than Jelgava Palace. As it was mentioned, I am a dean of the faculty, Ilmārs Dukulis. I'm on the combine harvester. It's designed by our first-year students. Each year they are designing new vehicle for the dean. Of course, it is not driven by engine. Students are driving this combine harvester. What about faculty? As the Vice-rector mentioned, we have 8 faculties, and engineering faculty is the 4th oldest one. Some years ago, we celebrated our 70th anniversary. Students, we have more than 650 students. It's approximately 16% of all university students. We are the second biggest faculty after the Faculty of Economics. Our faculty is interesting, not only engineering, also pedagogy. Pedagogy is approximately 1/4. Others are engineers. And engineers, we have all levels. One program, first level, professional program. Then the biggest part is bachelor programs, 4 different programs, master program and doctoral program. And of course, for today's topic, the most suitable are our bachelor level study programs, and 3 of them, machine design and manufacturing, applied energetics and agricultural engineering. All these 3 programs offers engineers for different companies. Each year, approximately 100 engineers are graduating, and maybe small letters, but that's only one example. Practice places this year and year before in these companies are working during their practice our students of program machine design and manufacturing. Some companies are big, some not so big, but big companies usually offer more than 1, sometimes 2, 3, or 4 places for our students every year. And I don't know how many of you have been at our faculty. That's why I prepared a small photo tour of our laboratories, something from each specialty. We have very good friends. Most of them are our graduates. Sometimes they are giving us presents. For example, this tractor is presented to our 4 years ago, when we celebrated our 70th anniversary. But this was not a Latvian company, Lithuanian company, Dotnuvos Projektai. And some other equipment is also usually offered by our graduates working in different companies. Sometimes they are giving these devices for us for all the time. Sometimes they are offering for season when we can teach our students. Then another part is related with motor vehicles. We have one laboratory of biofuels, and in this laboratory, as I'm not mistaken, we have equipment or complex of equipment that is only one in Baltic states. It's Mustang Dyno. It's a dynamometer on which we can drive vehicles and continuously measuring fuel consumption, exhaust gases, power, torque, and other parameters. And then, of course, design part, machine elements in practice and in computer-aided design programs. We are working with AutoCAD, SolidWorks, and starting from the first year students. Then different labs for hydraulics, modeling, micrography, mechatronics. We have CNC simulators before to go to operate real benches. They are acquainting knowledge initially on simulators, then real benches also. A laboratory of our Institute of Energetics has different equipment to test fuel, heat supply, thermal radiation, investigate hydrogen technologies. And of course, our students are very active. I hope most of you have listened Mehu dienas or Mehu days, 3 days in Jelgava every year. Last year it was 23rd time. This year will be 24th time. Different actions, competitions, and one of them is in this picture, lower corner, when students are preparing their cars for all year, and then this car is destroyed in 5 minutes. The last one is winner. Last 2 years, we started to take part in also one interesting competition. It is International Aventics Snowmobile competition. It's in Hungary. 12th time will be this year, I think. And last year we prepared 2 cars, 2 pneumobiles. If the first year our results were, how to tell, average, last year they were better. Thanks, Mr. Raviņš, because he helped to realize this project with money. and everything is made from zero. For example, this cockpit was designed for the smallest member of our team. Not only the boys are involved, also ladies, young ladies. And this team is continuing to work also this year. Then one more thing what we did, maybe not students only, together with teachers, we made or rebuilt ordinary fuel-driven Clio and made it electric, and also registered. If this rebuilding took approximately 1.5 years, registration 3.5 years. That's problem in our country to do such procedures. And as I mentioned, approximately 100 engineering graduates per year. We are trying to make them ready for companies, but not always they are so ready. And that's all for now. Thank you for attention.
Thank you very much. Thanks a lot. And since we're exploring the possibilities for the industry to get educated staff, educated new colleagues, workers, I'm very pleased to invite and to share the information about the other university. Let's give a round of applause to the head of Department of Material Processing from Riga Technical University, Mr. Artis Kromanis. Applauses, please.
Good afternoon. As it was said, my name is Artis Kromanis. I'm a head of Department of Material Processing, and my specialty, I'm responsible for courses. It's metal machining, computer-aided manufacturing, and for 3 years I'm also responsible for courses on lean manufacturing, because we try to be adaptive and active according to necessities and requests from industry. And they were saying, oh, it's good, machining is good, but sometimes it's good that students can understand process flow and importance of deadlines. Deadline really means deadline. Yes, you should manage. So we introduced this lean manufacturing course as well, where I'm responsible. And speaking in business terms, our most valuable asset is our students. Yes, they are qualified. Not all, of course, but most of them are qualified. And according to polls, RTU is a university mostly highly recommended by Latvian employees. And by being here today, I would like to use this opportunity and invite you to the career days in Riga, in Kīpsala, in the biggest exhibition hall. We are organizing career days. So you could meet your future employees. Nevertheless, during lectures, I'm saying to the students, you have two options: be employee or be employer. Yes, do business. And of course, our university is really big. We have 8 faculties: electronic faculty, architectural faculty, building, civil engineering faculty. Today I can speak about my faculty of mechanical engineering and especially about my department. And what we can offer to the industry is technical expertise, especially in testing materials. We have done a lot of examinations for materials if something has been broken down or there was some kind of collapses. Yeah, we do testing and give our expertise on this. And if you are wondering, is there any 3D printer, metal printer in Latvia? Yes, it is. And we are printing right now metal test samples and testing mechanical properties of metal printing materials. And we are also giving commercial courses. I would say commercial courses. They are paid courses on hydraulics. We have really good cooperation with Festo. We have Festo laboratory on hydraulics. We give courses on industrial engineering. It's CNC machining and computer-aided manufacturing, like using CAM programs, cloud-based CAM programs, and CNC programming. Yes, we have really good cooperation with another company in Latvia, Naglis and Air, which helped us develop really good leading CNC laboratory. And of course, we want to be global, and we manage it. 3 years ago, we found open door in CERN, and right now, one of our professors from my department, actually I'm not so happy that he is there, not here, because he needs to give lectures, He works right now in CERN, trying to get Latvia membership into the CERN. How it relates to the metalworking? How? Simple. CERN has a lot of projects, they have a lot of ideas, projects, and they should be manufactured. CERN approached us, please, we need to manufacture this and this. At the moment we have one small project which we can manage, yes, but it seems that in the future when we will get more cooperation with CERN, we will have more manufacturing requests. So be ready. Please introduce yourself, your business to us, and maybe after some time we could have some kind of cooperation in manufacturing for CERN. And of course, how can I know for how long we are cooperating with CERN? We are cooperating at the moment for 2 summers. How I know it? Because each year one of our PhD students have practica interna in CERN. Yes? Last year our student was there printing, doing 3D printing magnets for big colliders, particle colliders. And yes, we have also this strategic aim to be more commercial. It sounds a bit strange for educational institution, but to me, to be commercial, to help industries, and also to create companies with the help of RTU, to bring these companies to the business. One of our success stories is RTU Design Factory. From this factory, many startups have evolved, and they have, I would say, they have everything for prototyping. 3D printers, milling machines, turning machines, laser cutting machines. So if you have some projects and you are looking forward who could help you to design, prototype, produce as well, we are open, and you can easily contact Riga Technical University Design Factory. And of course, for cooperation with industry, we have not many departments, but we have some departments. It seems that government institutions are keen to make a lot of departments. But as it was said in one of the previous panel discussions, I think by Mr. Peterson, he said, in Latvia it's really good. You can contact directly to the decision maker. So if you would like to cooperate with us, please call our rector, call our dean, or call me. Okay, thank you very much.
Thank you very much, Artis. And for the companies that are most interested in a smart manufacturing, and I believe those are like all companies, at least majority of them, I'm inviting our next speaker to present the possibilities that Institute of Electronics and Computer Science can provide us, you, with the researcher from Institute of Electronics and Computer Science, Mr. Kaspars Ozols. Applauses, please.
Good afternoon, and thank you, Nikita, for a very warm introduction. So today I'm going to talk about our experience in supporting companies to create smarter and more efficient production and manufacturing. But before we go there, I would like to give a short introduction about us. So who we are public research institution specializing in smart embedded cooperative systems in the fields of health, mobility, space, production, social challenges, safety, and security. And as you can see, one really strong direction is related to production and smart manufacturing. Here you can see some facts and numbers about us. So we were founded in 1960. Currently, we are about 100 people working in 4 different laboratories: signal processing, time measurement, an embedded system, and cyber-physical system laboratories. Recently, in the last international evaluation, we were rated the highest in Latvia in the field of engineering and computer science. In the last 5 to 7 years, we have invested several millions of euros into state-of-the-art equipment and infrastructure to perform research at the highest level. And as I will show you in the next slide, we have dozens of scientific and industrial partners all over the world. So here you can see we have international partners such as Infineon, Siemens, Philips, Volvo, Daimler, etc., etc. But not only international companies. We are also strongly collaborating with local companies, as you can see here. For example, La Telecom, ABB, LMT, and so on. Our main research directions are intelligent transport systems, wearables, radar technologies, robotics, precise time measurement technologies, remote sensing, biometric technologies, embedded and cyber physical systems, wireless sensor networks, including Internet of Things, and of course signal and image processing. And as you can see, at least 4 main directions are closely related to smart manufacturing. To better understand what exactly we are doing in the field of smart manufacturing, in the next slides I will give you just 3 examples of our development. So the first example is computer vision-based system for robotic systems. In this case, the challenge is to detect, recognize, classify, and by robotic arm pick up randomly dropped objects from the box or from the pile. To solve this challenge, we have created a system which consists of active infrared vision sensor, industrial manipulator, and some intelligence, which in this case is artificial neural networks and machine learning, deep learning algorithms. And as you can see in the video, by using this approach, it's possible to grab some dropped objects, in this case cans, from the box. But the system is not limited only to the cans. Actually, you can train the system quite easily to pick up any other objects depending on the customer's needs. The second example is related to silicon rod growing. Perhaps all of you know that in our nowadays telephones and computers we have chips which are made from silicon crystal. To make these chips, first you need to have a silicon wafer, and before that a silicon rod. One of our partners is actually using a technology which is called silicon crystal growing technology, where silicon rod is obtained by slowly pulling out of the liquid the steam, allowing silicon to crystallize. In this case, the speed of pulling out the seed determines the diameter of the silicon rod. And in previous case, this diameter was adjusted, the speed of the pulling out the seed was adjusted manually by human, which is not efficient, and the deviation was about 40 millimeters, as you can see. When the silicon rod is ready, it is smoothened by the narrowest place of the silicon rod. So at the end, there is a lot of waste material. So the challenge is quite clear. We want to stabilize the diameter of silicon rod. What we did, we developed a vision-based solution which allows to automatically adjust the speed of pulling out the seed, thus giving the precision of approximately 4 millimeters. And the last example is related to the use of wireless sensor networks in order to increase performance of different mechatronic systems. In this case, we use real-time wireless sensor network node, which is put on the load or on the hook of the crane, and which measures the crane's load, acceleration, and orientation. And as you can see in this video, by connecting this wireless sensor network node to the management system of the crane, it's possible to create an anti-sway system. We are also working on different solutions to make the system more autonomous and long-lasting, which includes energy harvesting solutions and also wireless energy transfer solutions. At the end, if we are using this system, it allows us to eliminate load oscillations, also improve displacement time, and as well allow non-skilled workers to safely operate with a higher performance with the crane. In the last 2 slides, I just wanted to show you why and how to collaborate with EDI if you want to make your manufacturing or production smarter or more efficient. So actually, there are several reasons why to collaborate with EDI. First of all, our huge experience in research and innovation, our scientific excellence, cutting-edge technologies, and state-of-the-art equipment. Secondly, we have both new minds, creative minds, as well as very experienced researchers, which are working in the development, integration, testing of smart embedded cooperative systems. Also, in our premises, we have some support for business. We are the commercialization laboratory, as well as hackerspace site is located in our building. Also, depending on cooperation approach, we can actually share development costs, which is in the case if company needs some specific solution, it can get it much cheaper. And last but not least, we believe if your company is introducing some smarter and more technological solutions in your manufacturing and production, it will definitely increase your competitiveness in today's challenging market. But the question is how to collaborate. Actually, there are plenty of possibilities how to collaborate with us, starting from collaboration in some international programs like Horizon 2020, Eureka, Eurostars, etc. Also, it's possible to collaborate via contract research, for example, through competence center project. Also, we have innovation vouchers and technology transfer grants where we could successfully collaborate as well. Perhaps the most easiest way to collaborate with us is via direct contracts, but this will cost some money for you. And last but not least, of course, there is also some possibilities to commercialize our already established developments by creating some spin-offs or buying some licenses from us. So this briefly it about us, and thank you very much.
Thanks a lot.
I was just putting here the video. I thought that we will have a question session right after my speech, and this would be the background, but okay, it's fine.
How long is it?
It's about 2.5 minutes. This is just to see what else we are doing. And
I think we can watch. Yeah.
Okay.
Yeah, just have a seat.
Okay, thanks.
Is it as intense music playing at the institute all the time?
Yeah.
Yeah? Oh my God. Alrighty, I think it's a very healthy practice for the panel discussion meant to discuss the education, to invite the representatives from the industry, from the other part of these relationships. And as a industry representative, I want to invite, and with your help, with a warm round of applause, the founder of Mechanika Engineering, Mr. Artūrs Žipris.
Okay. Hello, everybody. I would like to say a few words about what industry would like to see in the future as a product from universities and how we would like to see our employees. First of all, about expectations. So what do we expect from the school, actually, not only from the university? We expect that university will give us some special knowledge, something that we can't just take from anywhere else. Then we expect that people who accomplish universities or any school is prepared somehow to work, to be productive, to be ready for the labor market. And the third thing is to rise productivity, not only in a particular company, but to do it in the matter of country and maybe even abroad. And now is the question, do we get it now in the Latvian education system, or let's call it anyhow. And I think that every one of us knows, or probably those who are somehow involved in the Latvian economic system and industry, we know that it might not be completely like we expect. And then, of course, sometimes we have a question why it is like that. And many newspapers and many people claim that it's only about the financing. So we are really tight, or we have insufficient financing for the schools. And I tried to dig a bit deeper in this thing and how to say, investigated, made some little investigation in some numbers that is publicly available about our schools. And for example, here we can see that, for example, Latvijas Lauksaimniecības Universitāte, it's a Latvian Agricultural University, that the number of students actually is decreasing, and the funding or expenditure per student is increasing. Of course, it's not like a straightforward line, but again, it's increasing. The similar situation is, can be seen in Riga Technical University, and here we can also see that expenditures per student are less than here in Jelgava, but again, it's rising, and number of students is decreasing, similarly as actually in maybe all of the Latvian schools. And then, if we would like to dig even deeper, then we need to compare with someone, because we can say, okay, it's a lot of money or it's insufficient, but then to whom we compare with. And then I started to see numbers from the foreign countries, and I understood that it's really hard to compare in the absolute numbers, because these are quite different economies and quite different wages in all of the countries. And because of that fact, we like to introduce some percentage of GDP. that maybe gives us a little more sense of what actually our country is doing in supporting schools. And according to OECD data and according to some state data, we know that for the universities we get something like 1.5% of our GDP. And we could say that, okay, so, and where are we with this number? And then I know that over the OECD countries, the average is just 0.1% more than we have here in Latvia. So I could say that probably it's not the worst, or even I would say that it's a quite good situation here that we have so a lot. Of course, every one of us knows that we want more, but it's the matter of resources. And from that, I conclude that maybe financing is not the really problem that prevents us from getting all the expectations come true. Then I started to think, okay, then how could we maybe make the situation even better? So if the financing is not a problem, then let's see where is it. And then I understand that maybe it is number of schools and students. So of course it's always hard to say that some school or I don't know any institution is not necessarily needed. But here we can see that actually from year 2004 till 2060, actually we have no drop in count of schools, but we have a really significant drop of number of students. And here are data about 4 more or less technical schools. It's Ventspils Augstskola, it's Reizeknes Academy, and Latvian Agriculture University and Riga Technical University. So these are numbers just about these 4 schools, because we are here talking just about the technical things, not all the situation in our country about that. And then we understand that actually it's a drop by 30%. So if we have a student drop by 30% and we have increasing funds, if we talk about expenditures per student, then I would like to say again that maybe the problem is somehow related with the count of schools. And then what we get is actually, I would like again to compare with the foreign countries and say that student-teacher ratio here in Latvia is maybe not so good. I mean that average, as you can see, in the OECD countries are something like 15.8, and in Latvia it's a bit higher, but it's not a problem because in technical universities, those 4 I called you before, is something like 8.9. It was in 2004 and is decreasing. That means that we have actually less students per teacher than other universities. And despite that fact, we have lack of professional skills in some places. So we have many good teachers, but we have somehow not fulfilled all our expectations from the students. And I think somehow and sometimes maybe it would be too loud to say that it's bad quality, but if we are dividing all the money we have to many educational institutions, then we have, of course, lower grade maybe academic stuff, or we can attract lower grade educators or lecturers, and that are also spread across the more schools that it could be. And of course it leads also to lower grade or low grade, it depends on the university, technical equipment and laboratories that from my side of view as an employer is needed to become more professional. And of course, when we are fighting for the students to get the financing for the university, then we are somehow decreasing some requirements for students, and it's also a problem in my opinion. Okay, so I'm out of time. It was meant to be just 10 minutes, and so all that might lead to lower education quality that we are actually expecting. And of course, I have some assumptions, so maybe what it will be better to do to see better quality students in the future, and for everybody as an employer to hire higher quality personnel. And here you can see actually what I was talking about is decreased number of schools and increased academic staff potential. That means that we could attract again more professional people from the industry. Of course, it's dependent situation. The better universities we have, the better people we have in the industry, and vice versa. So it's not like just in one direction. And I really believe that we should increase requirements for students, because I know some examples from Germany. I have an employees from Germany, and I know that they need to accomplish like 10 years, 10 weeks practice before they can start studying mechanical engineering, for example. So they really know what they are going to. And of course, by even increasing the amount of money, we could increase amount of technical equipment in the school, and thus give us students and more options to practice, and then bring this knowledge, bring this innovations and to the enterprise, to the companies where they are working in. So that's all for today. Thank you very much.
Thanks a lot. And please take a seat, and I'm sure we're going to have some comments. Please, gentlemen, can you comment on what you just heard on the last presentation?
Yep. Can I?
Sure, sure.
Okay, first, I always like the approach of the average temperature in the hospital. You know, average temperature in the hospital is 36.6. Of course, somebody has fever, 42, and somebody is in the room temperature. And those numbers which were presented by the last presenter are coming from this story. Because I just don't want to go into the numbers, but I would just inform, especially foreign investors and people who are coming to Latvia as a potential place for metalworking and engineering, that during last, I would say, more than 10 years, education system in Latvia did get roughly 70% of minimum expenses needed to educate students. Expenses to one student is around 70% of the one which was calculated by Ministry of Education. So when what we are doing as university, we are doing a lot of research in order to invest our own money in research and in studies to support study process. Why I'm talking about this average temperature in a room? Because the colleague didn't look at different programs. For example, we have program in veterinary medicine, which has multiplier of expenses of almost 5. So in order to prepare good veterinary medicine person, we have to invest 5 times more than in economist. So the understanding of engineering is much more just in equipment and comparison of how much it was spent. In reality, we didn't receive money, but we still have good engineers, and all those who are managing, running those companies in engineering and metalworking are our graduates from all universities. So this is the first. Second, why we are decreasing in number of student intake. It's a very important message, because with the decrease of birth rate in Latvia, of course we have the pool where we can take less good, knowledgeable students who know good mathematics, physics, and chemistry as the basis of engineering studies. And even though if they're joining our universities, they are being taken out by companies instantly because they already have background in mathematics and physics and chemistry, and the second year they're already working and they're receiving bigger salaries than professors in universities. And if somebody will blame that universities are having money, I will compare in numbers. Freshman who is joining, I think the colleague's company as well, will receive 1,000 and more euros per month. Our professor is receiving that's just 1.4 thousand euros per month, but he invested in 25, 30 years in building his knowledge. Can we compare these systems, and can we talk about bad or good? Our people are doing our best to train people, and we are doing a lot of research. A lot of research in the high-end technologies. Of course, what do we want and really would like to have? Feedback from companies how to change their programs. We are doing this every year and on an instant basis, but companies right now are just fighting for employees. There's a fight. Who will repay somebody, the engineer? So I feel a bit upset, but in reality it's a bit different. We are doing a lot, and well, that's it.
I see.
Simply.
Arti, what's your opinion?
I'm not so involved in strategy of developing education, but what can I say? I agree. I could say I agree to both sides. There is, yes, student decrease, but in the same time, as Mr. Laizāns said, in bachelor's, students, if they are in a third course, they are already working somewhere. It's like a headhunting. Companies are coming, asking, we have problems in technical field, and by the way, do you have some free students, some able students? Because I think the main qualities nowadays for students is this ability to be ready to learn something new, to be adaptive to new technologies and so on. Yes, we cannot give complete student, and I think industry knows this, but they know that if the student studies in our university or in yours as well, yes, he's capable student. Yep. So he's very, how to say, demand is very high for such students.
I see, great. And Kaspar, do you have thoughts on the last presentation which you heard?
Yeah, actually, we are independent from many of the universities, so for me it's hard to comment this university thing, but once I was a student as well, and I am quite familiar with the Finland model of education, which should be considered as well in Latvia because it's quite excellent in my opinion. And if we step back, one of those things are related to professors. I believe we need a new generation of professors, and also we need to get the best professors. And as mentioned before, with those salaries we have right now in universities, you can't get a best professor because there is no competition.
Do you want to become a professor?
Not exactly. And
Not exactly.
this is not my, let's say, personal challenge to teach. I rather do a research. But I think we need this competition, at a very high level competition. Then we will have the best professors and lecturers, and then we will have the best education.
Competition, you mean competing for this position, like the professor? I see.
Exactly.
I see. Very interesting. And Artur, I think a question for you is, we heard a lot of your, how do you say, statements, you know, and ideas. My question for you, and the last question for today, I guess, is how are you going to help the educational system to move the steps, you know, towards the perfect or at least good enough kind of level, in your opinion?
Excuse me, I didn't get your question
Oh, you
fully.
didn't? What are your steps, if there are any, to help out the educational system in order to make it as you wish?
Okay. My steps actually is at least to bring something out from the box and to show that here are some problems, to indicate them, to prepare students who want to practice. Actually, it might be my company, it might be other company, it doesn't matter.
Are you taking interns?
Yes.
Okay.
I'm trying, and I totally agree that, of course, my thoughts was just like measuring average temperature, yes, but that's what I wanted to say, and what my colleague Kaspars said also, that to attract better professors, we need maybe to decrease number of schools. Then we could get more finance, and then to attract the best professors. And other things that I can do is I can just I don't know, offer any help if I can help somehow. So I'm not a professional in the schooling system. That's why I can't tell exactly what's needed to achieve those results. But I know that Latvian education system is going in the right way. And new financing system, which was made like 3 years ago, it's also good. And so.
I see. Is there any closing remarks from?
Just one very important thing. We really, education system, I will talk from real all higher education system as that. I'm really asking you business people to come to universities in many roles, let's say. First, like lecturers, to come with your experience, and of course then we expect you to come also as an investors in education system. Otherwise, we are still in a position of fight, and we are in a position of the blamed ones. You are saying that you need engineers, but we can act, it's quite inertial position, 3-4 years. So please come with your vision in the future, and we will change according to your needs. But of course, we need this support, technical, engineering, and also financial, and support from your position to all our system, for government system, understanding that we are really, education system really is the one which is the key system for Latvia and for you as employers and the investors. We will do all our best, and we will make world level specialists for you, but we will need support. Thank you.
Thank you very much. I think that was a great closing remarks. Thanks again very much. Please, you can take seats in the audience. Well, that's actually pretty much it for the presentations and speaking and panel discussions. There is something I want to tell. I want to close today's forum with. But before that, some practical information. Business-to-business meetings are still happening till 7 p.m., right? Like to your right when we had lunch. For now, you can get right to the entrance to go to visit the whole Jelgava Technical School, you know, to see how it is, what has been developed in here. At the same time, at the first floor, if you are registered, if you did register, go down to see the Jelgava ice sculptures. And so the Technobus is still here till 7 p.m. And the bus is to Riga again. We have the dinner starting at 7 in here. So dinner is going to be served in this place. And the buses are going to leave at 9 and 9:30, 2 buses. And to conclude today's event, I can say that the industry is having really a phenomenal opportunities and phenomenal number of opportunities. There are many of them with the Industry 4.0, where you can cut the costs, you digitize, you improve the bottom line, and many more. And of course, massive, huge challenges. And I believe with a technical talent is being one of the biggest challenges. And therefore, my personal belief is that we have to increase the pace of learning, the pace of trying and learning from each other, and which can be done by forming unions, forming partnerships, forming friendships, groups, associations, you know, as Mr. Laizāns said, you know, just join together in order to learn faster, in order to improve from each other, in order to learn from one's mistakes and failures. And let's learn from each other to grow together and to be the most developed region for mechanical engineering and metalworking industry. Thank you very much. That was a pleasure to be with you, and we'll see you in the next year. Thank you.